So picking up where we left off with the 6.2 material, we were working with multiplication properties of exponents. As a quick reminder, with those, we were focusing on these three main properties here, the product rule, the power rule, and the product to a power rule. And as a reminder with those, these are all essentially designed to be shortcuts for going through and um, simplifying our answers down. You can work these by expanding everything out and then simplifying the bases. So expand it all out and then condense it down together. I wouldn't recommend it only because the numbers and the amount of writing can get kind of ridiculous. So the shortcut properties are the ones that I recommend here. Now we went through 1 through 7 yesterday, so we're going to pick back up on 8. We'll do 9 and we'll do 10, and then we'll jump on to our next section from here. So looking at number 8, we are given the quantity 9x squared y, all being raised to the third power. So a couple ways we can go about organizing this for ourselves. I think there's pros and cons to both. At the end of the day, it's a matter of you picking which method you would like to use and then just committing to that for that problem. So the first one that we have, our first route that we could take for organizing this, is noticing that I have a product of things inside the parentheses. I have 9 times x squared times y, and this entire product is being raised to the third power. If I have that showing up, and we saw that with example 7 yesterday, but we're working with that again now, what I can do is state that each individual coefficient and then each variable and its exponent is going to be raised to that individual outside power. And what I mean by that is we're going to write this out as having 9 raised to the third power. I have x squared to the third power, and then y to the third power. So I break this thing down into smaller parts, each being raised up to the third power, cubed, another way you could think of it. At this point in time, 9 to the third power, you can use your calculator to enter that in, or you can expand that out to 9 times 9 times 9. Either way, whichever route you would like to take, we should be getting to 729. We have x squared raised to the third power, and this is going to use our power rule, which states that if an exponent is raised to a power, the two exponents will multiply together, and that's going to give me x to the 6th power, and then y, technically to the 1st, if you want to write that in for yourself, all raised to the third power. That's going to give me y to the 3rd at the very end. And from here, I have my final answer, and I'm good to go. Now, if you wanted to do this with an alternate route, you can expand this thing a little bit. I wouldn't recommend doing it too much, but you can expand this out and then recondense everything down. So what that would look like instead is noting I have everything inside the set of parentheses raised to the third power. So everything in the parentheses is going to multiply with itself 3 times. So I get 9x squared y times 9x squared y times 9x squared y. And again, with multiplying things, I'm now just going to multiply the same bases together. So I have 9 times 9 times 9. That is going to give me 729. I have x squared times an x squared times another x squared. That's going to give me x to the 6th when I apply the product rule. And I have y times y times y, which is going to give me y to the 3rd power. Again, using the product rule. So as we're seeing, we have 2 ways of going through this. There's probably a few more that you could use to get to the answer, but on the homework or on the test, I'd be perfectly happy with either of these routes that you would want to take. I would recommend trying to use the exponent properties a little bit more if you can, because I think that simplifies things down. It doesn't mean we need to write as much on our paper, but again, both will work, and I'd be perfectly happy with whichever one you had written down. I think most instructors would be too. Okay, so looking at number 9, we have been given 2/5 a to the fourth b cubed times 15 b to the third. And again, this is one of those ones where it looks like there's a whole bunch of stuff going on, and there kind of is, but I really recommend, as best we can, being willing to rewrite this problem in slightly different formats, and that could help us see, hey, this thing isn't actually as big and complex and terrible as I might initially think. And we're first going to note that we have everything inside the sets of parentheses are multiplying together. Everything in here is multiplying together. Everything in here is multiplying together. And the two parentheses are multiplying together. What's great about this is this gives us some options on how we want to potentially rewrite this problem. And we want to try and multiply things together that are like terms or have like bases, meaning I want to multiply the coefficients together. I want to multiply the a's together, and I want to multiply the b's together. They're going to end up all together at the very end of the problem, but along the way, how we're multiplying them, we're going to do those in smaller, more controlled parts. So what we can do with this to rewrite this, and again, I think this is just a really helpful way of just allowing us the freedom to say, I'm just going to manipulate this thing a little bit and make it easier to look at. So I'm going to put the coefficients next to each other just to show that those things are going to multiply. So I can do that by saying I have 2/5. I'm going to multiply that with 15. I then have a to the fourth, and that's going to multiply with a. We can just write that out there. And then I have b to the third multiplying with another b to the third. So I've not made any actual progress in simplifying this thing down, but what I have done is I have set up a scenario where now, hey, here's the two things that can multiply together. They are right next to each other. Here's the two things that multiply here. They're right next to each other. And there's the last two things that multiply together. They're right next to each other. And this can be really advantageous as you go through these problems to say, hey, and now I don't have to worry about going all the way across all this extra information and numbers. It's just all right condensed here. So when I multiply these things together, let's see what we get. So I have 2/5 times 15. If you want to use your calculator and use MathFrac with that, you are welcome to do so. Although I believe, yeah, this ends up just being the nice, easy number 6. I have a to the fourth times a. This a is assumed to have an invisible 1 hanging out there as an exponent. So a to the fourth times a to the first. The product rule states that I'm going to get a to the fifth. The exponents will add. And then for b to the third times b to the third, I'm going to end up getting b to the sixth. Once again, the exponents will add together because the bases are multiplying with the product rule. And there we'd have our final answer for number 9. Again, there's a few other ways that you might be able to creatively reorganize and rewrite this for yourself. Whichever one and method you would like to use, you're welcome to it. But I think some kind of rewrite can make these things a little bit easier for us. It's not required, but you do need to make sure you're keeping track of coefficients multiplying together, a's multiplying together, b's multiplying together. Rewrites can really help with that. So consider that as a potential tool that you can use as you're going through these problems. All right, and looking at number 10, our last example that we're going to be going through with this material, I have 3x to the 11th times 4x squared y times negative y to the 7th being raised to the 4th power. And we are told to simplify this thing. So simplify means I have to look to PEMDAS and do that first. So I can't do anything inside the set of parentheses, but I do have this exponent outside here that's affecting this entire set of parentheses. So I need to deal with this exponent and this parentheses first before I do anything else here. Now the way I can work with this is first just bring everything else down exactly as it was. No changes there. And then I can deal with what I have written inside here. So how we deal with this last part, we do have a couple options with this, but again, kind of, again, once again, pick one and commit to it for the purposes of getting to our answer. So this negative, we can think of this as being an invisible -1 in front of the y to the 7th. So we can do this to some extent in our head. We can think of -1 times -1. So it's multiplying by itself twice. So a negative times a negative is a positive. Multiplying that by yet another negative, third one, that's going to give us a negative. And then that negative times a fourth negative is going to give me a positive number. So whatever comes out in this last term is going to need to be a positive thing. I can go ahead and just not include a negative down here. I then have y to the 7th raised to the 4th power. I'm going to use the power rule here. So these two exponents are going to multiply together. And I'm going to get y to the 28th power. Clean up this y here just a little bit. There we go. And now I've dealt with all of the exponents that are outside of the parentheses, and now I'm just left with stuff that's multiplying together. If I wanted to, I could rewrite these things like I did in problem 9, where I put the coefficients next to each other, then the x's next to each other, then the y's next to each other. If you would like to do that, you are welcome to do so. I'm just going to show you that we don't need to do that with these problems. But again, if that would be helpful to you, please do not hesitate to write it out like that. I have 3 times 4. That's going to give me 12. I have x to the 11th times x to the 2nd. That's going to give me x to the 13th. I think there's a typo in my notes. I think that should be the 13th power. And then y times y to the 28th. Remember that this y here has an invisible 1 that's hanging out up there in the exponent spots. This is actually y to the 1st. So y to the 1st times y to the 28th, that's going to give me y to the 29th power. I think the typo in my notes has this listed as 12x, 12x to the 12th power, when it should be to the 13th power. So typo on my end there. It should be to the 13th. But these are our last 3 examples of going through and using these exponent properties with different types of problems. I'll go ahead and pause here. If you guys have any questions regarding these 3 examples, go ahead and put those into the chat, or give me a thumbs up, or I'm ready to go. We're ready to move on to the 6.3 material. I'll give you guys a minute or so to type anything in if you have any questions. All right, 9.3, multiplying polynomials together. The biggest thing that shows up in this entire section that we want to have nailed down is the distributive property. This is the all-star for this entire section, and it's going to show up in every single one of these problems that we go through. So we're going to start off with doing these in smaller parts, and then we're going to expand out to the bigger, more terrifying, air quotes, looking problems. So we'll start with multiplying monomials together. So what we're doing with this is we're going to take the monomial in front, whatever it is, and it's going to distribute through and multiply to everything inside of the other polynomial. If the other polynomial is a binomial, then it's going to multiply to 2 things. If it's a trinomial, then it's going to multiply to 3 things. If it's got 4 terms, 5 terms, whatever, then the monomial is going to go through and multiply to each of those terms in that other polynomial that's been given to us. It should be noted with this entire section, you want to show as much work as you need to with these problems. We will see with some other problems further down that this is going to become an absolute mess later on with how much stuff we have for multiplying together. So take any and all extra lines that you need to write this stuff out for yourself, reorganize it for yourself. All of that organization goes really, really far with these types of problems. So don't discredit yourself if you have to do that. Lean into that as much as you have to. Let's take a look at our first 2 examples here, and then we'll take a look at the further down ones with some more advanced stuff. So for example 1, we've been given 2x times 7x minus 8. Now again, the distributive property, that's the all-star, that's the highlight, that's the big thing with this entire section. So I need to identify the 2x multiplying through to 7x and the 2x multiplying through to negative 8. Now, as necessary, this is you on an individual level, do this. Actually write out for yourself 2x times 7x minus 2x times 8. This right here is technically an optional step. If you can keep track of all of these computations and their results in your head, you are welcome to do so. I am not expecting you to be at that point after, what has it been, a minute and a half of us doing this material. So if you need to write this out for these problems and all of the future ones that we do, please keep doing that. We have 2x times 7x. I can multiply those together. That's going to give me 14x squared minus, then I have 2x times 8. The 2 and the 8 multiply, and that's going to give me 16x. I then always look to see, can I combine any like terms here? And I have two terms with x's in them, but if we remember back to 6.1, we have two requirements for like terms. The exact same variables, so they both have that, which is good, and the variables also have the exact same exponents. The first one is an x squared, the second one is just an x to the first power. So the exponents are different, meaning I cannot combine these things together. They must stay separated, and this is as far as I can go with the problem, and I have my final answer. We'll take a look at example 2 now. And once again, I'm seeing that I have a lot of variables showing up, but hey, I'm telling you guys now, guess what we're going to use? The distributive property. Same thing like we did before. It's just going to be the monomial in front distributing to everything inside here, and then take any and extra steps that you need to actually write that out for yourself. Well, I had a negative times a positive, gave me a negative 6a to the third b here. A squared times a becomes a to the third. The b just comes down as it was. I have a negative and a negative double sign showing up here, so that becomes a positive answer. 3 times 4, that's going to give me 12. A squared just comes down. B times b to the third, I'm using the product rule, and that's going to give me b to the fourth. Now, can I combine any like terms here? No, I cannot. They both have a and b in them, which is great. However, the variables have different exponents, meaning I cannot combine anything together. These things must stay separated, and this is just going to be my final answer right here. Can't do anything beyond that. That's a quick overview of how we're going to be using the distributive property for our monomials when we are multiplying them together. Now, looking ahead, as you guys can probably anticipate or think with these, we're just going to be doing a bunch of this distributive property over and over and over again. So if we're noticing in our second lines that we have here, see how we have a whole bunch of stuff that's multiplying together? We're going to start to have bigger and longer lines of more things multiplying together just like this. You are not doing anything wrong if you're thinking, wait a minute, I'm going to have 1, 2, 3, 4, 5, 6 more things multiplying together. That is the nature of these problems. That's just what happens with them. There isn't really any trick to get around that. That's just the nature of what ends up happening with them. So go ahead and take a look at our notes for multiplying the bigger polynomials together here. And take a look at our process for that as well. So when we are working with multiplying polynomials with multiple terms, this is what we're going to be using. And I am warning everyone right now, deviate from this and Skip writing steps down at things down at your own peril. A lot of people can do the individual multiplication things in their head, which is great. Please, for your own sake, write these results and write these things down along the way. They become really messy really fast. Examples 3 and 4 are going to highlight that pretty clearly as well. So what we're doing first, we're going to take only the first term of the first polynomial. We're going to distribute that and multiply it with each term of the second polynomial. So just doing the distributive property and setting that up like we did in our two examples above up here. We're then going to repeat this with the second term in the first polynomial and distribute that through. We're then going to repeat that with the third term in the first polynomial and distribute that through. And we're going to do this as many times as we need to until everything in the first polynomial is completely distributed to everything in the second polynomial. Once we've done that, we are going to actually multiply things together, and then we're going to combine like terms from all the results that we get from steps 1 and 2, however many times we need to do that. So as you're reading through this, I'm hoping people are writing it down. I'm going to give us some a pause here for a second and let you guys write these things down. But keep that in mind if you're looking ahead and going, wait a minute, I'm going to be writing a lot of stuff down, especially with example 3 and example 4 here. Yep, that's just the nature of what these things end up becoming. And yeah, we need to get comfortable with writing these things out, and that's going to go a long way with these and hopefully make them a bit easier. So we'll give you guys an extra minute here or so to write these things down or write the process down for yourself if necessary. And then we'll jump over to do some of these examples. A couple notes to make while you guys are doing this. If you've ever heard of the FOIL method, that's technically just using this process. However, it only applies to multiplying two binomials together. So if you are saying, hey, I'm going to FOIL out number 3, we technically can't. It's just the distributive property. And it should also be noted right here, if you guys are writing these things down, please put some stars by this last bullet point. If you are multiplying 3 or more polynomials together for a problem, and we're going to see this in example 4, only work with 2 of them at a time. Do not do everything all at once. A lot of people want to multiply and distribute everything to everything all at the same time. I'm telling you now, we want to resist that at all costs, resist that urge, break that habit. Just work with 2 things at a time. Okay, our first example is giving us the polynomial 2x plus 3 times the polynomial x minus 1. So based on our process, we were told that we want to distribute or take the first term of the first polynomial, distribute and multiply it to each term in the second polynomial. So the first term of the first polynomial is this 2x. The 2x is going to multiply through here, and the 2x is going to multiply through here. Again, as necessary, write this out for yourself. Just like we have there. If you would like to actually do this multiplication in this step, you could do that if you wanted to. I'm going to skip that for now. We're just going to keep all the extra work visible here for our first example. We're then told in our process, repeat this with the second, third, etc. terms in the first polynomial. So the second term in the first polynomial is this positive 3. Positive 3 is going to also multiply to everything in the second polynomial, and we're going to write that out for ourselves. So I have 3 times x, and I have 3 times 1 showing up. Make sure that we are keeping the sign the same, and we can just let those sit right in front here as well. Now that I have everything written out as multiplying, or distributed, I should say, I can now start multiplying each of these things together. And using our previous properties, we're going to be getting 2x squared minus 2x plus 3x minus 3. I then combine like terms where I can. I have two x terms showing up here, so these can combine together. They cannot combine with the x squared term because this x has a second power, or raised to the second power attached to it. So only these two can combine in the middle here. I'm going to get my final answer of 2x squared plus x minus 3. If you wanted to, you could write a placeholder 1 in front here. Just be aware that the online program that you're using might ping you for that and say, hey, it's not fully simplified, because we generally do not write the invisible ones that show up around numbers very often for our final answers. On the test, I'm fine with it, but just as a heads up on that for online programs that you may or may not be using, they will just want X there. But otherwise, that is our first example, just using the distributive property, taking it slow and steady, writing everything out, keeping everything nice, neat, and organized. I think all of that, those small little things add up to make these much easier. Okay, looking at our second example, we have more things that are showing up, so more stuff that we're going to have to do and write out potentially. Just going to have to bite the bullet on it and go through it. So like we did with our first problem, we're going to take the first term from the first polynomial, and we're going to multiply it through to everything in the second polynomial. And if you're noticing that, yeah, we have a whole bunch of stuff that's written out here now. Yep, this is the nature of these problems. But we write these out like this specifically so it's nice and neat and organized to see, hey, I'm just going to do this one piece, this one piece, this one piece, and so on with that. Otherwise, you would need to be doing all of these calculations and the sign changes and figure out where they combine together all in your head, which I don't think is very fun or easy or plausible or any of that. Let's go ahead and simplify everything here down, and then we'll combine like terms for our final answer. And then getting to n to the third power minus 4n squared minus 19n plus 42 for my final answer. I'm trying to use this little highlighter thing to highlight this and show some other stuff, but it's not letting me. There it goes. Again, for combining like terms, you can use whatever you would like to reorganize that for yourself. I think if we were underlining things, here's some like terms here. We have some like terms here. We just combined those together with our previous, like we did in our previous problems. Okay, so now we're going to have now we've got the big monster problem. We have a trinomial times a trinomial. So if we thought number 2 had a whole bunch of stuff written out, we're going to have a whole lot more showing up here, unfortunately. So again, take this slow, take this steady, write as many steps as you personally need. I don't think there is anything wrong with it. We are not trying to solve all of this at once. Take it in very small, very controlled parts. I find rushing these is where things go horribly wrong. So just follow the process, and that's what we're going to use. So the first term, this a squared, we're going to distribute that through to everything in the second polynomial. We're then going to distribute negative a to everything in the second polynomial. And then we're going to distribute the positive 3 to everything in the second polynomial. We're going to write that out. Then we're going to multiply things together and combine like terms. Okay, again, slowly but surely, step by step, we are getting this thing fully simplified. Now I'm going to look to combine like terms where I can. I'm going to go ahead and do some underlining for my like terms, and then we'll combine them. And we should get to our final answer here. Have a to the fourth plus 9a to the third minus 15a squared plus 38a minus 24. I should note to everyone as well with this material, this is probably the most advanced problem that I could give you in terms of the number of things that are going to multiply together. However, you can in future math classes see problems that are even bigger and grosser than this with more things multiplying together with the distributive property. And I'll once again note that yes, these problems take time, but I think it is beyond worth it to take these 2 extra lines to write everything out for yourself. I think it makes things way clearer. Um, I think a lot of errors show up with these problems when we do not write this stuff out. So I would recommend getting in the habit of doing that and actually writing it out and see if that works for you. A lot of people it tends to. Okay, number 4. I have 3 polynomials multiplying together. I have a monomial in front, I have a binomial in the middle, and I have another binomial at the very end. So I have 3 individual things that are multiplying together here, all of which are going to require that I use the distributive property to get to my final answer in their own unique way. So, as noted previously, and hopefully everyone has those written down, or maybe you have the lecture notes up nearby in a different screen. If we have 3 or more polynomials that are multiplying together, only work with 2 of them at a time. It does not matter which 2 you choose, but only do 2 at a time. So we could multiply these first 2 things together if we wanted to, and then we'll deal with what comes afterwards. Or we could multiply the middle and last polynomials together and then deal with what comes afterwards. Or I could multiply the first and the last polynomial together and then deal with what comes afterwards from there. Any of those things work, but again, only work with 2 polynomials together at any given time. If you want to do more than that, you're going to over distribute and you are going to get wrong answers there. So for this problem, we're going to work with just our first 2 polynomials, the monomial in front of x and the binomial of x minus 1. I'm going to just not worry about 2x plus 2. It's just going to sit there for the time being. We will deal with it, but that comes later. So the x is going to distribute through to everything in that set of parentheses. And that's going to give me x squared minus x. Now this result, this new combined result, is still multiplying with 2x plus 2. So I've essentially taken these first 2 things and I've condensed them down to be one single polynomial. It's a little bit of compression there, or simplification, and awesome, we did that. Now I have a binomial times a binomial, much like we did with example 1, and I can use the distributive property like I did previously, write that out, and then combine like terms and get to my final answer. So I'm going to distribute the x squared to everything first, then the negative x to everything, multiply and combine like terms. And I get to a final answer of 2x cubed minus 2x. Notice how when we were going through and multiplying these things together and we're combining like terms, we have a positive 2x squared, and then we have a minus 2x squared. The positive and the negative, um, the positive and the negative here will combine together and they become 0. So 0 times x squared, that's going to cancel out entirely. And that's where that x squared goes. It completely disappears from my final answer. Okay, so this is our last example for the 6.3 material with multiplying polynomials. I know I'm not going to be able to get all of it in. Well, actually, maybe I can. These are our four main examples. I would say these are the ones you want to spend some extra time with. But again, as we're going through all of these problems, really lean into the process of actually writing these things out for ourselves, really taking the extra time and care to make sure everything is organized properly, signs are set up where they need to be and not maybe spacing things out as necessary on your paper could be helpful, but definitely take the time to write these things out for yourself, and do not rush your process more than anything else. Okay. So with that, that is going to be the last of our new material for today. I'm going to go ahead and end the recording here, and I'll take any questions that you guys have over this material or anything else that we've covered past few days or the homework or anything like that.